Okay, hi everybody. Welcome to Sarah's Drake's Lounge Australia. Paul Butler is down in Melbourne. He's the head of the Australia group. Quick announcements, April 8th and 9th is the Western Conference. Go to the Sarah store and check in online. I think it's $10 this year to be online at the Western Conference. And we'll also be they're also in conjunction with the solar eclipse, which I think is on the 8th. Your own Robert Lucas will be there, and I think he's actually given a pitch for solar eclipses down there. So it should be a good time. Sarah Journal, if you're a member and you've not got the Sarah Journal, you should contact me because that just went. The link for it just went out, and the new initiative is that we are working with the ARRL engineering book editors to put a radio astronomy section in that book. We did last year put it in the 50th anniversary of the antenna book. And now they want to do it again for the receiver side. And they're very interested in how do we get the receivers to pick up these very small signals. And so what I did is I started out with the people that did the antenna book. The editors had cut that down to just the antenna sections. But now I started with those same articles, and we're going to try to emphasize the receiver sections. So I am still looking for input for that. If you've got, and basically the input would be, based on objects, masers, hydrogen, pulsars, FRBs, things like that, with almost any kind of antenna, and emphasize the receiver and how do I get, my noise down to be able to receive these very small signals. Things like that is what they're interested in on this one. Okay, I'll turn it over to Paul. Go ahead, Paul.
Yeah, thanks, Rich, and hi, everyone. The couple of apologies from this end. Andrew Klekachuk in Tasmania is an apology. I think he might be busy dealing with signals coming from the sun. The sun's been extremely active, as you'll be aware, over the last few days, and that tied in very well with my conference presentation, which I'll talk about very shortly. And also an apology from Roger Heap. He's setting up a local community radio demonstration, interestingly, at the local showground. And he tells me he won best beer in the show. So I'm not quite sure whether he's busy with radio or busy with beer, but one or the other. Yes, I haven't heard from any of our local people. We did have our radio astronomy section meeting last Monday. The general report there is that fixing up our 8-meter dish at Leon Moe Radio Observatory just outside Melbourne is progressing. They've got all the hardware to reinstate the lifting of the dish. The challenge at the moment is they want to put bellows over the thrust bar to keep all the dust out and the dirt. It's very dusty up there. So they're just working out the best way of fitting the bellows, and then that should be back in operation very soon. So that's from there. I thought I would just quickly go through what I was doing yesterday. So yesterday, Friday in Melbourne, we had a physics conference for teachers, the annual one, PhysCon, and I gave a paper at that conference called Radio Astronomy in Schools. There was quite a lot of interest in the nature of radio astronomy. It's a big mystery to many people. But I'll just quickly whiz through the key parts of the PowerPoint I should be able to share that screen. I won't do the whole thing. The whole thing took an hour, but I'll just give you the essence of what I was talking about. So able to see the screen at the moment, radio astronomy in schools?
Yes.
And really what I was trying to get across was that this is an opportunity to learn to do science, do physics, rather than just learning about science or learning about physics. And there's very much a trend to just trotting out, this is what science is and so on, without actually getting the students to do actually some real science. They tend to have recipe style prac work, labs as you'd call them. Recipe style, they just follow the bouncing ball and they get some data and they come to some conclusion. And so the idea was to pick up things from the Australian curriculum, which talk about students designing their own experiments, getting their own data and presenting it, interpreting it, making sense of it. The Victorian curriculum draws on the Australian curriculum. Each state is able to interpret the Australian curriculum its own way, but it's consistent in that it talks about students planning and conducting a range of investigations. And then our own VCE, Victorian Certificate of Education, which is the last 2 years of school, builds on it again. Activities including problem solving, decision making, and individual and group practical work, including laboratory experiments, field work, simulations, and so on. So that was the rationale. And I talked about the physics of light, light in its broadest sense, light, not just visible light, but light coming in different types. And that gives us the electromagnetic spectrum. And we can build up composite images by using different sensors. This is cold hydrogen. This one is mid-infrared, and another mid-infrared with the artificial coloring put together as this composite image on the left-hand side. I talked about the fact that there are some windows in the Earth's atmosphere. There's obviously one around the visible ultraviolet infrared in the middle here, which is our everyday sunlight. But also there's a window over here in the atmosphere in the radio band, which is what we're particularly interested in. But if you try to collect microwaves or ultraviolet down here, this gamma rays, X-rays, you need to put things in orbit to get rid of the atmosphere that's blocking it. For example, James Webb, and I talked at length about James Webb and showed some images. That was sent 1 million miles away. It faces away from the sun because it's receiving infrared, and we're getting some amazing pictures, including gravitational lensing in this one, and pillars of creation on the other side. So we can quickly whiz through some of this, tune our radios to different frequencies, and that gives us this opportunity to look at what we call space weather. And that's exactly what we're experiencing at the moment. Well, there have been some radio blackouts actually with the most recent eruptions from the sun. Electromagnetic radiation, 8 minutes to get here. Particle flux, anything up to 6 hours, and then the solar wind just getting stronger and changes in the magnetic field. So I sent them towards the space weather site in the US and the space weather site at our own Bureau of Meteorology, and we talked a little bit about those. And we said, well, monitoring the sun, you can monitor the sun remotely, or you can do it like I do with my little C-star telescope. This is not the most recent image of the sun, but it's quite a good one. That was way back in November, I think. This is my little C-star robotic telescope. And so you can keep an eye on the sun. It takes 5 minutes to set up. It could easily be done in a school. and have a quick look at the sun, see what's going on, and then match it to the space weather information that we can get there. Then we can get the same information via SOHO, and we looked at some live images of that, including that massive sunspot that's there at the moment. Again, not a recent image, but you can animate it. Then I talked about drift scan, so very, very simple Yagi antenna, which you can buy. I think I found one for about $90, $90 Australian. And or you can build one because the matching is not critical for a receive antenna. Use something like stellarium to predict where the sun will be, so you can lock your antenna in the right place and then get a drift scan of the sun. So these are things that could very easily be done at minimal cost in a school. SIDS and super SID, and build the antenna, just add a bit of PVC piping and some copper wire, and get a SID, super SID via SARA, and away you go with the shark's tooth image that we get. Not only do we get radio signals from the sun, we get them from Jupiter, so that's a little bit harder, but all the information is there. I pointed them in the direction of all the software, so we can predict IOA, IOB, IOC. Then we got to hydrogen, the hydrogen line and the spin flip, and the emission at 1420. Very, very weak, but get a big bucket, collect it, send it down. This is my own one that I made. Send it into the waveguide, the little antenna down the bottom. Trip to the local hardware shop, Bunnings in our case. Well, I think you call it Home Depot or something. Slight variation where the waveguide is a bit different. And then this dish, which we're all familiar with the LNA and SDR receiver. And some of my graphs, which I've collected over time. Radio eyes, so we can predict, well, what the sky is doing and map the Milky Way. And then I gave them a few leads. That's the chip and it's a hydrogen line. That's Alex's article on what is it, RTL, SDL. The Victorian Space Science Education Centre is worth a look, and if I click that, it should actually go there, I think. Yep. So if I put that up there, this is the Victorian Space Science Education Centre website, which is a public website. And if you look at their programs in here, we see there's a whole load of things that they do on site. They've got a simulated Mars environment. Kids dress up in spacesuits and go and collect samples. And then under the radio astronomy section, they have their own dish. Not that far from Heathcote, we're looking at the possibility of some interferometry with their dish and ours. That is available to government schools in Victoria. I work in non-government schools, so I'm not able to access it, but they're trying to change the funding there. And then Astronomical Society of Victoria, talked about that as a good source of information, and the Leon Moe Observatory with our dish soon to be back in operation, and all the streaming that we do. And then Sarah, I mentioned, and showed them the website, showed them what's available in the resources. And then finally, the SALSA online radio telescopes, which are in Sweden. Again, I can click that and allow. There are 3 radio telescopes, Torval and Brage. I'm not quite sure exactly how to pronounce them, but you can just set up an account for free, make a booking, and then you connect to one of the 3 radio telescopes. You send it to where you want it to point in the sky, collect the data, download the data and process it. And that's all free, just quite amazing. And then, that's Salsa. And then I mentioned Zooniverse, which has got lots of citizen science projects that kids can get into, and finished off with a little mention of meteor banks. So if I stop that share, that's just a quick run through of that session yesterday. And as I say, there was quite a lot of interest, so I'm hoping that there will be some follow-up locally, and perhaps we might get some more SARA members out of that exercise. I'll just keep pushing that one. Just while I'm on the conference, as of yesterday, there was a session on muon detectors, and that's not something that we've talked about. So the question was, is that really radio astronomy? I put it in the radio astronomy basket because it's stuff coming in from space. Some of you may be aware that there is an old gold mine in Stawell, just west of Melbourne, and they've reconstituted the gold mine, and they're putting electronics right down. I don't know how many kilometers down it is, 2 or 3 kilometers down. And part of this muon detector strategy is part of that program. That's a fully funded government program. So they're going right down into the earth so that most of the emissions from space are absorbed by the rock, and then the muons come through and they can do measurements and get some information about muon flux. Their kit's about 2,500 Australian, which is for a school is just not possible. But I've said, well, can we borrow a set? Can we, having borrowed a set, can we move it around various schools? They thought that was a good idea, and we'll see what comes of that. But the muon detection stuff is actually quite interesting. A lot of good physics in that we would be interested in, but also that would be good for school students, including the whole special relativity. How do muons even get down to the Earth's surface? They should have decayed because they're only formed 4 kilometers up by collision of cosmic rays, and they should only travel about 500 meters. But in fact, they do come all the way down through 4 kilometers because of special relativity, time dilation, or length contraction, depending on whether you are the particle, the muon itself, or you are the muon detector. That's actually in our VCE course. We actually teach special relativity, and we include muon detection. So it fits in very well with what's happening in school. I'm just hoping that somehow we can get hold of some muon detectors at a reasonable price, or just borrow them for free and use them for some good science. So that's those. Now, related to that is the article. Someone sent around an article or a link to an article in Physics Today, and I forget who sent the article. I don't know whether it's someone. Was it? I don't know whether it was Marcus or Nathan or someone sent an article in Physics Today. There's no paywall on that. You can go to that article, and it's all for free. Very, very good summary of many of the resources for radio astronomy that can be used by educators. And I've been in touch with the author, and she responded very quickly and said, well, she will put SARA on her list of resources. She hadn't got it so far, but it's now on that list. the thing she said was there are so many resources, it's very hard to condense them down to give beginners, absolute beginners, a good starting point. Where is a good starting point that doesn't actually, confuse them totally? And I thought that's something we might discuss at greater length to see whether, there are good. I think there are some good leads on the SARA website, but we need ways to get people in to actually get some data, to get some recordings or some observations in a way that's very, very accessible, very easy. And then as they do that, yeah, thank you, Ted. That's the one. It's in Ted. Just put it in the chat. Yeah, I recommend having a look at that article, and it might be something that we focus on. Or a group of us, perhaps a subgroup, have a look at how do we get people started. That was the big question at the end of my session yesterday, because I gave them the overview as you've just seen from the PowerPoint. And yeah, it's overwhelming. There's so many things that you can do. Where do you start? Perhaps we have people who are already established and we can pair beginners up with people who have some experience so that they're guided through the first initial stages of getting into radio astronomy. So that's what I've been doing. Any thoughts, any questions before we move on to the next stage? That was quite a lot of information packed into quite a short time.
I actually have a couple of questions.
Yeah, Marcus.
So your C-Star optical telescope, can you live stream from it? Is that possible?
That's interesting. That's a good question. And I don't see why not, because it comes over Wi-Fi to my iPad, and then in theory I should be able to connect my iPad to Zoom,
right,
and live stream. I might turn it on while other people are talking just now and see if I can do that.
Yeah, the reason I ask is that we're considering doing a eclipse event at the observatory. And the timing is kind of tight. We're still working on getting the thing remotorized, but if we do get it working, we're going to have an event that's advertised locally for the eclipse. So we'll have an optical telescope plus the radio telescope will be monitoring the solar output during the eclipse, and we can show the radio output disappearing for a bit while the moon moves in front of the sun. We're not on the path of complete totality, but we're at like 98%, which should be more than good enough.
Well, I guess the answer is it comes through to a tablet. That can be Apple iOS, or it can be Android.
Right.
It can be an iPad. It can be a phone. If you can then stream that out again,
right,
then you're in business.
Yep. Okay. That sounds good. Then we just have to find budget to acquire one.
Yeah, and they're not hideously expensive. I'm sorry.
Oh, can I say something?
Yeah.
Yeah,
This is Robert Leek.
Yeah.
Okay. Well, I'm going to Dallas for the conference as well as the total eclipse. And last meeting, you made a comment about C-Star. And
Yep.
and my emotional was, I've spent so much money with all the, the big telescopes and the filters and, the ASI Air and all the CCD cameras and stuff. So I took your comment and I put my emotions in my pocket and I went out and I bought one. Okay, I actually bought one, and I've actually got some recent images of the sun because of the solar activity and stuff. And when I was talking to the people that sold me, one of the he's a member of the club also, and what he said was he was going to go to Mexico and he was going to use his C-Star to stream the total eclipse from Mexico. And I thought about it and I said, well, geez, I like the sea star, and I've done some imaging like you have, and I'm going to take a sea star to Dallas, and hopefully, figure out how to, like you say, stream, the total eclipse from Dallas. Okay, but I have other instruments, that I plan to take, and I don't know if I can stream them or not. I'm still trying to get them. One of my contacts is Daystar. They make the hydrogen alpha, and all that kind of good stuff. And I have a PST, but but it seems that it's so difficult to get the dumb thing to actually. I mean, it works, okay, but it's more for a visual. Okay, so I'm trying to work the Daystar to get their 80 millimeter quark. I actually have one, but it's for iron 14. Okay, and I'm not planning to take all of my telescopes, and it's a it's I don't know if you know what a Suburban is, a Yukon in America. When I take all of my gear, it fills up one of those trucks, type thing. So I'm not taking all of that stuff. Okay. So, so anyway, I'm working on how to stream the total eclipse from Dallas. Okay. I don't know if that helps anybody. But anyway.
So sounds like a good move, and perhaps keep in touch closer to the time so that we can actually see the stream once you get it going. I mean, it will be easy enough to practice it here. As I say, once you've connected it to your tablet, whatever you've got, as long as that tablet's on the internet, in theory, you should be able to stream it out the other side.
Well, the thought, I have Google Fi on my worldwide telephone, and it's an Android, and with luck, I can get the Android version of the Sea Star app, and possibly try to stream it.
Yeah.
But the sun is very active right now, and the images that the Sea Star, even with a 2-inch aperture, it's quite impressive as to what it can do.
Yes. Do you have any examples, Rob, that you can share now?
They're on my iPad, not on my computer.
Okay.
But while you're talking, I'll see if I can figure out how to change all of that.
Yeah, you can on mine, if you do share screen, you can actually share the screen of an iPhone. That comes up as an option.
I can do that. Have I interrupted everything, or do you have a plan on what you're going to do now?
No, I was going to go around the Australian participants. Are you in Australia at the moment, Rob?
I'm in Sydney still. I'm here for another couple of weeks before I head off.
Yeah.
Do you want me to continue?
Yeah, keep going with whatever you've got, and then we'll just go around. I can see Duncan there, Joe's there, Michael's back with us. So we'll go around the Australian, but you carry on, Rob.
Okay, so to carry on, what I've done is, people keep asking for specific scans of areas in the sky. So what I've done is I've started putting together a trackable antenna drive. Okay, and for me, what that means is I don't really want to put my expensive tracking mounts out in the weather 24 hours a day, 7 days a week. They kind of rust. Okay, so what I've done is I've I don't know, are you familiar with JCAR? Here in Australia? Anyway, JCAR has their antenna motors on sale for like $30 Australian each. So I've bought several of those. And what I've done is I'm having mechanical brackets made, so that they can make that into an alt-azimuth drive, and have the electronics to actually drive those things. I've not put it all together, but the parts are being made, right now. And so hopefully in the next couple of weeks, have an inexpensive all-weather, drive for an antenna, make it pointable. Okay, so that's coming up. Rich said, I'm working on a presentation for Sarah, about eclipses. And what I've done is I don't know if I've mentioned, I have a high resolution spectrograph. And basically, one of the things I do is to image the spectrum of the sun's corona during total eclipses. So I've been working on a presentation for that and putting together, some pictures and stuff. Another thing is, two of my colleagues that I've traveled with to eclipses for years, are both, NASA outreach presenters and that type of thing. And I've been talking to them about, one's going to, Rochester, New York to, image the eclipse, and he's hoping for, for clear skies. And the other one's, going to Carbondale in Illinois, to work with NASA and this type of thing. So I've been reaching out to them about, what's really, really going on. Let's see, my observatory out at Waruna, I've put the pier in and hopefully go out in the next couple of weeks before I go to America, to put the Rosmandy and the telescope, in there and have another play. What else? And the sea star interrupted everything. And, the catastrophes at the house with tree roots and stuff is still going on. And what I did see was, you mentioned, muon detectors. When I was in India, I got to, when I gave my presentation to the PhD students there, about eclipses, one of the professors took me over, and showed me his muon detector. And you talk about this. His was large. I think he uses scintillation detectors. I don't know if you're familiar with what those are. To look for the muons going through, hitting something that puts out a light, and you have a photon detector. The scintillation detectors are the same thing that you use in X-ray diffractometers. Anyway, so I know about those things. And it's still, I struggle, like you said, you're either going to do physics or you're going to learn about physics. And I bounce back and forth between the two. And the next thing is, you did your presentation yesterday. Last night I saw Randall Warth from Western Australia. I don't know if you're familiar with him. He gave a presentation to the local astronomy club about radio astronomy, and what they did was something similar to the scope in a box, but they used a metal walk, and put a dipole in it. And anyway, Randall, he even used one of the slides that you just presented about the flip, for the hydrogen, atom, and the photon that comes out of it. Anyway, so there's so much going on in radio astronomy as well as optical astronomy. It's just somehow, I agree with you. Somehow we need to tie this all together. Randall in Western Australia doing his thing. People, my friends in America, doing their thing. Somehow there's got to be a way to. There's just so much information out there. There's got to be a way to pull it all together. And at the presentation last night, what I saw was, people want answers, but the answers, like one of the questions last night was, how do they make those really interesting, pictures, with radio telescopes and what's out there, and the answer to that is it's more complex, and it just goes over people's head about how to really do it, and one of the interesting things last night was, our 1 meter, scope in a watts is a 1 pixel. It's 1 pixel on the picture, and so it takes time after time after time, to create these images. So anyway, I think I'm busy. Next,
I think we all
questions.
are. It sounds like you're very busy. That Sea Star, if you're traveling with it, I understand you have to take it into the cabin with you. You can't check it into the hold because of the battery.
But keep in mind, I have places in both countries. What I'm doing is I'm negotiating with Thousand Oaks Optical, and I'm just going to buy one. And I don't know how to get it to Dallas, but and I'm also working with Daystar to get their 80 millimeter port, And, I don't know if I'll have them delivered to Dallas or what we'll do. But I think the issue with the C-Star, it's the same thing as my DJI, the drones and stuff. It's the battery issue. Okay.
Yeah.
If you take the battery out, then that you just have to find a way to buy a new one when you get there.
Yeah. Yeah, it's the battery that they're worried about on the plane, certainly. Yeah.
Yeah. I also have other things that have the large batteries, the large lithium ions that they don't like.
Yes.
Anything else, or can we go move on?
Very good. That sounds like you've got plenty on your plate there, Rob. Certainly, I think the muon detector is quite an interesting one. The one I saw yesterday is a scintillation device. It's actually two scintillators, and you can put them on top of one another, and then they do experiments changing the spacing or putting absorptive material between, and then they move them apart because they say that the muons actually come as a shower, and they're trying to get a feeling for how big the size of the shower is. You don't just get one muon, you get quite a number coming through at a time. And the plan, what they're trying to do, this is from CSIRO, but through a private company as well. They want to get, well, it's certainly within Australia, because Australia has such a width from all the way from Perth to the East Coast. Get these muon detectors ideally in schools where they can just be plugged in and then the data can be harvested. And they want to do that certainly across Australia, but then in the longer term, put them out across the world, because one theory is that these muons, every now and then, there is a massive storm of them, which would light up the whole of the Earth, basically, that the whole of the Earth would be bombarded at the same time. And so if you have a network of distributed muon detectors, they would all respond at the same time. And that would help to see whether this theory is in fact correct or not. It's a bit like the Blitzortung lightning detecting. So they are distributed citizen scientists with these little lightning detectors with a very accurate clock, GPS clock in them. And when it detects the signature of a lightning strike, it sends information to a central server with a timestamp. And then the central server triangulates, and that tells you where that lightning bolt was. And that's well-established technology. So there's no reason why we couldn't do something similar with a muon detection network as well. The technology is there already. That's something to think about as we move on. So, Rob, that's everything from you. Is that right? Yeah, you're on.
I'm trying to, figure out how to share the screen. Do you want me to do that?
Oh, yeah.
How do we do that?
So if you go to share screen, the green button
Here's
down
a
the
share
bottom.
screen. Okay,
And then
let's see what happens.
On mine, it says iPhone, iPad.
No, I found some pictures that I put up. I have them on my screen.
Oh, you're on screen, right? Okay, excellent.
Yeah.
Well, should share that screen. You should be right.
I did a share screen, but what happened? Can you see the screen at all?
No, nothing's happening at this stage.
Sorry about this.
Do share screen and then, oh, here we go. Yep, that's working now.
So you can see the images?
Yep, got it. You see the M42. That's
see
a really
two
good
pictures
one.
of the sun.
Yep.
So this is what, these are just recent photos. And the M42, I set up the C-Star in the backyard here in downtown Sydney, and I took that image.
Yep.
and you can see the two, active areas of the sun.
Yep.
For 50 millimeters, that's actually very good, and the stacking and all that type of stuff.
Yes. What was the exposure time on M42?
I think it was 16 minutes or so.
Yeah. It's
amazing
yes. It's
for
an
what it
amazing
does.
piece of, yeah, it is. It's for the price and for the technology. I mean, basically it's ZWO or ZWO equipment miniaturized down and stuck in a box. That's also what it comes down to.
Yeah, I agree. Okay.
Yeah, very good. So just say stop share and it'll go away.
Have to find it first.
It should be.
Thank you.
Yeah,
We're back?
that's it. Yeah, we're back on normal. Yep.
Okay.
Very good. Well,
thank you.
Thanks, Rob, for all of that. On my screen next is Duncan. Duncan, do you have anything that you want to tell us about?
Yes, been doing a bit of ELF work. It's more in the building and testing phase, but this is I'm going to put on my screen yesterday's result. A couple of X-class flares came through. So here we go. So ignore the time base. It's just coming out of GNU Radio Companion. The time base is incorrect. But you can see the large, I think it was X6.3 yesterday, yes, towards the right-hand end. So that's just now the description of this is just a tuned coil in an aluminium loop with a short open circuit, sorry, on the aluminium, and a differential amplifier attached to it made out of 3 NE5534s. Could go for OP27s, but didn't feel like forking out for an experiment. And these are various stations around the world. So the processing is pretty rudimentary at the moment. It basically comes in on a coax. I'll tell a little story about that. It goes into a red Pataya SDR, which I'd had hanging around for years, and it wasn't doing anything, so I decided to use it. And then the data is processed in GNU Radio and written to file, and then I play it back in GNU Radio, and that's why there's a problem with the time base, because there's 32,000 samples in this, and the time base is wrong. Just a word of warning, I got caught by something I should have known about. Was when I first turned on the differential amplifier, which is basic. I've had not worked in audio for years, so I was a bit blasé, and yep, I got oscillation on the final stage of the differential amplifier, and yeah, I soon woke up to what it was, because I had this problem before. It's easily solved by putting a current limiting resistor in it to stop the capacitive load of the 20 or 30 meters of coax from causing oscillations in the final stage. It was very evident that the current demand could be seen on the power supply lines. So it was an annoying problem, but really easy to fix. So this is now running on a scheduler, which means it changes just before 0 hours UTC and starts up a new day. And that's about it at the moment. Yes, unfortunately, I had some nice flares to actually work with. Yeah, I think that's about it. So I'll stop sharing. Has anybody got any comments?
Certainly a good time to be doing that. There's an awful lot going on the sun at the moment. And it may
Yes.
be going back to our issue about the starting point for radio astronomy. It might be that the sun is the starting point, because it's always there, and there are lots of good, strong signals coming from it, or influencing VLF and so on. I'll give some more thought to that one. Well done, Duncan. Those some good graphs there. All right, moving on. Joe, you got anything from your end?
No, unfortunately not. I've been engaged in other occupations this last couple of months, so I've basically done nothing in the way of radio astronomy. However, I noted you spoke of the lightning detectors, so the Blitzenberg, whatever it's called. I can confirm that it works because during one of the storms, just 2 or 3 days ago, I was actually sitting in front of the computer and watching the screen when there was a lightning strike about 50 meters away from me, which which did show up on the Blitzenberg thing. It made me move. Let's put it like that. It was rather loud and rather frightening for a moment or two.
Yes,
But
it can be very scary.
yes, but aside from that, no, I'm afraid I've got nothing else to report.
All right. I think I recommend the Blitzortung system. It's you can go to there's now a world map, or you can focus right in on your local region. And yeah, once you get a strike, it very quickly comes up on the screen.
Yes.
And you can see that it draws lines to show you which stations have received it. And they receive them from long distances. It's a good system. There must be some way of identifying the particular shape or particular signature of a lightning strike. But yeah, it works very well. And you don't even need to buy the kit itself. You could just draw on other people's data. It's really good. Now, Michael was there, but Michael seems to have disappeared. So Michael Smirsky was around. Do we have anybody else in Australia? I think.
Paul, just one note.
Sorry, Duncan.
I have a long connection with a supernova 1987A from my professional work, and I just point out that JWST has put out a press release about it, identifying the neutron star at the core of the explosion site. So that was pretty interesting for me. No pulses have been detected because I think it's still cocooned, and the optical path or the shielding is probably still too high. It was when I last observed that source in 2009. It was quite bright. So as a continuum source. All right, that's me finished.
Very good. Yeah, well, James Webb is certainly rocking a few boats. I think it's some amazing stuff coming out of there. So, Rich, I think that's all from our end. There are some additions got in chat about muon detectors and various other things. Oh, here's Richard. So you might want to save some of those links, but that's probably Richard Flagg arriving. So, Rich, over to you for your side.
Okay. Yeah, all the links, all the chats that have links on them will be in the description underneath the video. You guys do that? Well, let's go to Marcus. And Marcus, why don't you describe your site, your facility, and sort of some of the stuff you're doing there?
Sure. I think a number of the people on here are already pretty familiar, but 2 years ago, we got an opportunity to restore a 12.8 meter former NATO satellite ground terminal for use in radio astronomy, mostly radio astronomy education, obviously, because as radio telescopes go, 12.8 meters is kind of tiny for doing lots of new research work. So we've had support from both a local university and Princeton in New Jersey So we've been just sort of marching forward with doing the restoration work and slipping in some observations in between. We haven't done any observing lately. Dan Marlowe was trying to do some pulsar observing for a pulsar, relatively strong pulsar that we were able to capture in transit mode. But the problem is we still have some pointing uncertainty, so he was not able to get any unambiguous results. And hopefully with the new system, we'll work on getting the pointing correct and going from there. We did have an incident the other day that I talked about on the mailing list, but there was no harm done. The instrument itself is fine. Our egos are damaged a little bit. My heart rate has finally come down, but we had an incident where the dish ran away on us. Unlike many dishes out there, this one has no useful counterweights on it. NATO just relied on brute force and ignorance to keep the thing where it was pointed. And you really, really, really have to be aware of that in all your procedures. And we had previously had a lot of procedures in place when we were testing new things to sort of prevent this sort of thing from happening. But we abandoned those the other day, and we shouldn't have. So the dish ran into the stop at relatively high speed, but there was no damage, just a lot of auditory drama. The only actual casualty in terms of mechanicals was part of our own drivetrain, and it was a $5 rubber spider from a coupler, from a shaft coupler. So, and that was the root cause. The problem was that the drive shaft into the main gearbox is in two pieces with a flexible coupler in between, and there was too much end play on one of those shafts. So when I commanded it to go up, it did so quite happily for about a second and a half, and then the shaft danced out of the coupler. And at that point, the gearbox was freewheeling, except we didn't even recognize that for several seconds, at which point it was too late to do anything about it. Like, by the time I would have leapt over to push the emergency off button, it would already have impacted. So, yeah, don't abandon your safety procedures even when you're comfortable. But we're back there on Sunday, and we'll be fixing the shaft problem, and then possibly doing the motor tuning procedure that we went there to do on Tuesday, and that was a bit of a disaster. And that's it. Like I said, we hadn't been doing much observing. We've mostly been doing, playing mechanical engineer.
Yeah. Sounds dramatic.
Yeah, it scared us, but the dish is, at least the support structure for the dish is wildly overbuilt. So I don't think it even really cared. We did a very thorough inspection of everything after the incident, and then we did a test move yesterday just by hand, like literally with humans on the hand wheels, and we moved it up like less than a degree, just to confirm that it would still move and there was no, there's nothing horrible in the gearboxes or anything like that. So, but you don't want to do it more than once. You definitely want to say, okay, that's the last time we do that.
Well, I tell kids
Comment?
at school. I tell kids at school you're allowed to make each mistake once.
Yeah. Somebody.
So Paul, comment? Sorry.
Go ahead, Robert.
Oh, I was going to say, I was observing with the Keck side telescope one time, and it started running away. And when I stopped it, and later I talked to the normal operator, and he said it's a good thing I stopped it because the Keck side telescope didn't have limit switches on it. It would have crashed.
Oh my God. Wow.
And I can tell you, what an adrenaline rush. I mean, it takes days for you to think that you got this multi-million-dollar antenna running away.
Oh my God. Yeah, well, the problem with our setup, the limit switch inputs were programmed on the controller. The problem is, at the time, the controller wasn't moving the motor. The motor was disconnected from the shaft. So it was a failure mode that the controller with its limit switch inputs wouldn't have been able to do anything with. So that, you know,
it's white knuckle time, that's for sure.
yeah, there's so
Thank you.
many different failure modes in large mechanical systems like this. And, you know, we're all learning. I've never actually, you know, managed a radio telescope this big before. So we're learning all kinds of interesting things.
Yeah, on I think DSN 26, which is antenna at Tidbinbilla, there was an incident many years ago where they're having a problem with the feedback loop, and to diagnose it, it had multiple cards in it doing the feedback. Each one was supposed to be redundant, and they pulled out the last card, and the thing went from horizon to horizon in 2 minutes, and it had aluminium crush blocks. And years later, I believe that the gentleman responsible for that day received a very nice piece of wood with the aluminium crush box on it as he retired. So,
yeah, well, actually, the Algonquin telescope, which was built by the same people who built Parkes, when Natural Resources Canada managed it for many years for continental drift measurements. And an operator one night ran the azimuth into the stops at full speed. And it was reported that the entire building shimmied when that happened. And it broke all of the 3, I think, azimuth bearings, shattered them. And then NRCan, Natural Resources Canada, said, "Oh, I guess we're done here." And the site wasn't used literally for over a decade. Because the quoted repair costs were over $1 million, which actually seems kind of conservative given what happened. But the people who are managing it now, it's a private concern. Ben was able to do it for under 100,000. So, and with innovative, I would describe it as innovative abuse of grad students. What they did was they jacked the entire telescope up off of the azimuth bearings using, I think, 30 or 40 5-ton bottle jacks and a matching number of grad students. And it was basically everybody in synchrony jacked the axis up off of the bearings so that they could pull the bearings off. And the bearings turned out to be an off-the-shelf item, just large and expensive. And that's how they were able to repair it.
yeah.
All right. Right. Well, the nice thing about this is we used to say in submarines, it's better to read somebody else's failure so you don't have it on your own. So remember that when you guys start messing with your own antennas, that this is good conversation.
Yeah.
Don't let it happen to you.
Well, I would say that, you know, if you are fortunate enough to inherit a big dish and have a team that's large enough to make that viable, that you need to have regular safety meetings, and you need to review your procedures, which, you know, if you're an industrial person, comes naturally. But if you're mostly, you know, electronics geeks and software people, it may not come naturally to you. So you have to be very conscious about actually doing it.
Yeah, I concur. The operator world is much different because it considers a far wider view of things.
Yep.
And it, having operated for nearly 30 years, yeah, you always get issues, and you can't have your safety systems become the problem rather than the solution. We had somebody's put in an electric fence near us, and one of our systems was based on pulse counting, but not differential pulse counting. And another part of the system failed, and telescope continued to move and corkscrewed a half-mile long section of antenna at one particular point in that half mile.
Wow.
And I can tell you, when you do that, it's not plastic. Sorry, it's very plastic, and it doesn't go back to the right position.
Right.
Well, to the eye it looks all right, but the radio, it's we knew we were off by half a degree when we jacked it back into position. In fact, we used the telescope to untwist it, but the memory is still in the structure, and it doesn't oil can out. So
yeah, well, we only did a visual inspection, obviously, and if the dish is now slightly out, since we know we have to calibrate positions and stuff anyway, it probably wouldn't be a big problem.
no.
Okay. All right, let's shift to some more people. Thank you guys. This is really fun. Ted.
Who, me? Gosh.
Yeah, you.
I don't have any big news. I keep playing with the software. I'm trying to put in tracking capability into my easy radio astronomy software. If you folks had a optical mount that was a go-to scope and could follow something across the sky, let's put a radio antenna on it and have Ezra record the data and kind of being able to track what that means in position, stuff like that. I'll keep you informed.
All right. And DSES for calibration put a raster scan capability on their mount. And the goal there was to pick an object in the sky and raster around it to come up with the brightest area. And so they actually get a nice raster picture. And they're using it for calibration, for pointing calibration, to get the right as-L, based on known objects. So that's another way to do that, Ted, is to maybe figure out a way to raster it a little bit to get the highest point center for calibration.
So if Ezra did that, what motor system would it support? Now we get a long list. So Ezra's not trying to control stuff, but it can record. It'll write down the numbers for you.
Oh, okay. All right. Let's go to Jason.
Yeah. I actually stayed on with Ted for a little bit after the last meeting, and we discussed his software a bit, and because I had been just using SDR Sharp with the IF averaging plugin, because I'm doing hydrogen line stuff, and so I ended up after that discussion, I ended up actually downloading and installing that software, and I've been playing around with it for the last week or so, and I've actually started to do some data capture with it. So that's been fun.
Yeah, you got any? Did you have any results you can show this group? Because this group probably didn't see it.
Not really yet.
Okay, that's good. That's okay.
But on a side topic though, when Paul was opening and talking about the muon detector stuff, I did about a couple of years ago. I kind of built I built a small scintillation based detector and it was kind of based on the Cosmic Watch design, except I didn't use the Arduino and all the fancy digital stuff. I just built I built a discrete logic counter, and I was more interested in the actual detectors themselves. And there you can build that for a couple $100. It's not. The only issue that I had with the Cosmic Watch design is that it required 2M level soldering, because it's all like really tiny surface mount components. So what I ended up doing was the silicon photomultiplier chip that it's based on. Instead of using, I got an evaluation board with pins on it, and that was easier to solder to, and I was able to get that working with some, the high speed op amp that they were using for the amplifier on the front end of it is surface mount, and so I ended up getting a dip adapter for it, so that I could, put it on a prototyping board and wire it up that way. And obviously, if you're dealing with super high speed stuff, that's not ideal. But with muon detections, you're not talking about super high speed, and it actually works fairly well. And like I said, it's only a few $100s. It's definitely in the accessibility range for a more advanced high school level, or and probably for a public school budget if you had some resources, at least a few resources to put towards it. But anyway, just thought I'd throw that out there. The scintillators themselves are like $35 a piece. They're a little this isn't a package, but it's basically a little square of clear plastic that has the scintillation material embedded in it, and that's what actually generates the optical signal that you're trying to capture. And then you have to wrap it in foil and make it light tight with a window to attach the SIPM chip to, so you can start collecting stuff. But it works really well. I mean, when I applied bias to that, just the SIPM module itself, and put it together with the scintillator, stuck it on an O-scope, I was immediately seeing spikes from muons instantly. I mean, I could see them. And then it was just a matter of amplifying the signals, turning it into a digital level signal that could be counted by something. And then the rest of it was just, kind of a foray into my past building discrete logic counter just for the fun of it, so. And actually this was kind of the result, if you see that here. The two detectors, there's one below and one above, and they're just on small evaluation boards. The scintillator is this thing covered in tape, and then the rest of it's just the electronics. So yeah, it's definitely accessible, both from a financial standpoint and from a technological difficulty standpoint, I think, for a high school level project. So I did put a link to my videos that I made, just documenting what I'd done with it a couple of years ago. I put that link in the chat, so if anybody's interested. But other than that, I mean, I've been trying to gather drift scans of M31 with my dish in the blue shifted hydrogen line. So it's the hydrogen line is blue shifted several hundred kilometers per second because of the proper motion of M31 with respect to us. So the blue shifted peak from the side that's spinning towards us is well outside of the regular Milky Way signal range. And so I figure if I can get enough, if I can gather enough time on with multiple scans and combine all that data, I might be able to eke a detection out of that blue shifted peak. So it might take a month worth of drift scans to get enough data, but anyway, so that's what I've been doing. I've been playing around with Ted's software, and yeah, it's definitely a work in progress. So that's all I got.
Excellent work, Jason. Is there the link to your videos, is there some kind of instructions on how to build that detector you just had?
Not really, but there is a pretty detailed documentation of how it works. So I do show the schematics, and I show an oscilloscope capturing the raw signal right out of the SIPM chip, and then I actually have it on dual trace, and you can see the raw spike coming out of the SIPM, and then you can see the signal processed version where it's actually pulse stretch to allow something that can be fed into the digital counter. And then the final stage is, I put it through a comparator and make it into a TTL pulse, so. And that I do show that, and the link is actually a playlist of about 4 or 5 videos, and they kind of go through all the details of it. But
Okay.
yeah, so that's what I got so far. But that Cosmic Watch, I think somebody else posted a link to the Cosmic Watch site. There's some really good information there. And like I said, I used that as my starting point, and I used a slightly different SIPM because it was a little less expensive and more accessible. But it doesn't really matter. I mean, you just have to it has to be sensitive enough to detect the signal, and it has to be optically bonded to one of the surfaces on the scintillator, and that's about it. So so I, rather than making a large one on the bottom surface, I just put a small one on the side, and it still works fine. So
Okay. Any questions for Jason?
I've got a question.
Go ahead.
yes,
The detector, is that an avalanche photodiode in the Geiger mode, or is there some other technology?
it's a silicon photomultiplier bonded to a scintillator, a piece of scintillator material, and then so the scintillator is coated in foil, and then I left a window in the center of one of the faces, and then I basically bond the I bond the silicon photomultiplier chip directly to the surface of the exposed surface, and then I wrap it all in tape to make it light tight. And then basically the silicon photomultiplier is a huge array of photodiodes that are they operate in a avalanche mode, I believe, and so it behaves very much like a photomultiplier tube, but it's solid state. They're somewhat expensive. That's the most expensive single part of this. You need 2 of them to build a coincidence detector, and they cost about, the evaluation board version of them costs about $87 or $90 a piece. Then everything else was, I mean, all the other electronics for the detector circuits were, peanuts. I mean, it was like less than $5.
So the
It
quench
does
circuitry,
what?
the quenching of the photodiodes, the circuitry to do the quench, is that included with the evaluation board?
Actually, it does it on its own. I mean, basically, you just bias it on and it works. You literally just, all you have to do is apply. You have to apply a bias of somewhere between 29 and 30 volts. It has to be in that range, and it's the sensitivity is very sensitive to how much above the threshold you are, and the threshold is right about 29 volts. So what I do is I end up connecting 3 9-volt batteries in series with each other, just using the snaps, and then I have snap ends on each end. It looks like this, and I mean, if they were actually 9 volts, it would only be 27 volts, but they're slightly above when they're new. So I find it puts me at around 29 and a half. Somewhere it's above 29, and as long as it stays above that threshold, you get detection.
You can't over quench them, you destroy them if you do that.
Yeah.
Okay.
Yeah, they apparently they're used for LiDAR on self-driving cars. So there was this one that I have now, I had to wait for like 8 months to get it because they were out. The global supply supply chain was completely they were completely out of them. But when they're in supply, you can literally go on DigiKey. I think I got them from DigiKey, but yeah, they're about $90 a piece. but they work really well. I mean, you literally just have to apply a bias and then couple the output signal to something that can read it. I mean, I literally bias it on, put a scope probe on it, and I can already see detections coming out of it. They're very narrow spikes, but as long as you have enough resolution on your time scale, it sees it just fine. So
Fun toys.
yeah, definitely.
Okay. Thanks, Jason. Excellent work. Don Latham. Can't hear you, Don.
Yeah, you're not muted, but your sound's not coming through.
Right. All right, I'm going to shift to Alex. Don, work on I think your mic's not plugged in or something. Alex.
Hey, good afternoon. I've been working on the circular patch Yagi. I finally got something interesting to work. I want to show you one slide. Maybe. What I finally got together is to be able to put some electronics near the antenna and not have RFI. And what this is, it has the little saw. This one, the circular patch Yagi uses the Sawbird up here, the LNA, and in here is the SDR power supply, and what's pretty difficult to see, but it's a USB to fiber optic extender. And so that's kind of neat that I've been able to run this thing over fiber optics. And this is the it's the 0.75 meter Yagi, and the scope and the box levels run right about 1 dB above cold sky. And so what's shocking is that this small structure has a stronger signal than an unmodified scope in a box. That's the story.
That is pretty impressive, Alex. That's pretty impressive, that signal.
Yeah, I mean, it really is. This is 24, 26 inches long, and the bottom dish is like 6 inches in diameter. It's the one I'm thinking, we're trying to think maybe to have Saracel has 15. This has 17 directors. But yeah, I mean, it's shocking. This size compared to a 1 meter dish, and this having higher performance than that is absolutely amazing to me. And oh, this is the thing, I'm getting no RFI out of this because I don't have a digital cable. Anything I've tried before, USB over Cat5 and anything else, the cable coming out would always create a lot of RFI into the antenna. This is clean. So, and it makes a portable, nice little portable system. The other thing was kind of novel is well, this is the first time I've ever used fiber optic cable for anything. And these particular extenders communicate over a single fiber element. They're bidirectional over single fiber, and they use WDM, which is a term I was unfamiliar with, and it's wavelength division multiplexing. One of the systems has a transmitter at 1310 and the other one 5050 nanometers, and so they communicate over the same cable.
All right.
I think
Questions for Alex?
I think there's some potential for schools in that, Alex. I think I'm following that very closely because it could easily get schools making their own.
Yeah.
I'm going to try to do one at a like a science project level. I'm thinking that foam center poster board for the discs and cover them with heavy duty aluminum foil. I just want to see if you can build something really simple on a wooden dowel. I just want to see how go to what a high school or middle school kid might do and see how well this thing works.
Yeah, sounds good. What we want.
I was wondering, Alex, do you know what your half power beam width of that 17 disc one is?
Yeah, I need to go back and look at some of the past videos I've done over the past couple weeks. The 0.75 meter has a 30 degree half power. The one that I started with, which is 1.5 meters long, is right at 24. It's wide. I mean, it's not the image is blurred as in time, but I mean it works pretty well. If you haven't seen what this can do, go back and look at the past few videos. I have the graphics. I have one of the contour plots through the Cygnus area of the Milky Way. But I mean, what's nice about this is that it's lightweight. I can carry almost everything out without breaking my back outside, and it looks cool. Some of the things that you see people make are out of like air conditioning duct into paint cans and stuff like that. It works, but this has sort of the space gun shape to it. And so I think it's intriguing just from the novelty of its physical design.
Yep.
Yeah, its beam width sounds about like it's similar to what my corner cube reflector was doing. Yeah, I think it's not the corner cube beam width is kind of an oval shape, and it's like 30 in the horizontal and 20 in the vertical.
Alex, when you speak of your videos, I think you want to be clear. These are the Drake's Lounge videos, just like this one, correct?
Yes. You do you know
So
that
they're all posted and folks can get them.
Yeah, you know that, Jason.
I saw the yeah.
The first one I think was in the end of was in December. Yeah. So go back and scroll through that because I've got little piecemeals of the progress of this, and you can see. But
yeah, I spent last the few days after the last week's meeting watching all the tutorial videos on Ted's software because I got kind of stuck into that, and he has a lot of material on that. So, but yeah, I'll go back and check that out definitely.
Have you made, Alex, have you made the jump to the pressed metal discs yet?
no one has come back with a quote on that, so it's kind of in limbo. I've handed out a couple of these. Mike Odie was on a few minutes ago. He's disappeared, and I want to see what someone can do if it's untuned. If you just put it together, see how well it works. But I could build the other three elements, the one element per system. But cutting 15 discs is slow. It's tedious. It's just a little bit more than something with which I want to become involved. So hopefully there's a way to stamp those out.
Okay. Thanks, Alex. Helen.
Oh, hello, everyone. Now, I've been sick, so I haven't done much, but I have limited mobility, but I did get a couple of textbooks and books on radio astronomy so that I can keep up as I get better. But the aggravating part is that I have family both in Texas and Maine that are right in the path of the totality of the eclipse, that I could have gone stayed at either part and got a bird's eye view, but I guess that's not going to happen. So that's all I have. Thank you.
Okay, well, take care of yourself.
Oh, I will. Thank you.
And I think Richard Flagg, I think you're the last one.
I think I am the last one. Sorry to be late. Really nothing much to add. I just enjoyed all the talks and all the information. Thanks, Marcus, for sharing your terror story with us. Kind of went through one of those myself a few years back, getting a azimuth tachometer feedback loop in backwards and spinning a 30-foot dish around pretty quickly. So that's good. All your advice is really good. You got to be very careful with these big machines. Thanks, everybody. Thanks, Rich.
Okay. Paul, back to you.
Nothing much more to add really at this stage. As I say, we're a bit light on. I think the ASV crew are probably up at Heathcote doing work up there. I know there's a lot of work to be done there. But I was just looking, so I think it's March the 23rd will be our next gathering. I'll see if we can summon up a few more from this end.
Okay.
But, no, nothing more. I think we might pull the plug early.
All right. All right. Thanks, everybody.
Thanks, Rich.
Yeah,
Okay.
thanks.
Goodbye.
See you.
Bye, guys.